In this X-Minute Math video, we're going to look at how to factor a quadratic polynomial where the x squared term has a coefficient other than 1. Now previously, we saw how to factor a polynomial where the x squared coefficient was 1. And we did this using a method called splitting the middle, or splitting the middle term. So if we look at a concrete example, let's say we're trying to factor x squared plus 2x minus 15. So the game we play is we look at the constant term and the coefficient of x. And our goal is to find two factors of the constant term, in this case negative 15, that sum to the x coefficient, which in this case is 2. Now, if we're methodical about this, we can find that 5 and negative 3 are such a factor pair. Okay? And we use those to form our product x plus 5, x minus 3. If this is all seeming a bit mysterious, this is just a quick refresher. I'd encourage you to go back and look at the original video. So what are we going to do if the x squared coefficient is not 1? Well, let's dive in with an example. So let's take 3x squared minus 5x minus 2, and I would love to factor this as a product of two linear factors. Okay. Now, I'm just going to lay out the method for you, and we'll talk a little bit about why it works at the end of the video. But the goal in this case will look a little bit familiar. So in this case, we need to work with all three coefficients. So the coefficient of the x squared term, the coefficient of x, and the constant term. So when that x squared coefficient is not 1, our goal is to find two factors of, in this case, it's the product of the constant term times the coefficient of x squared. So my constant term is negative 2. My coefficient of x squared was 3. Those multiply to give me negative 6. And I'm looking for two factors of negative 6 that sum to the x coefficient, which for us is this negative 5. Okay, so the one little difference here compared to when the x squared coefficient is 1 is we have to figure out this product first, and that's the number that we're hunting for the factor pairs for. Okay, so let's get to it. Let's look at the factor pairs of negative 6, and let's figure out their different sums, because in this case we want that negative 5 sum. Okay, so there's the easy ones we can start with. I know that negative 1 and 6 multiply to negative 6, but they sum to 5, so that doesn't work for us. The other easy one would be the factor pair 1 and negative 6. Oh, and indeed, those do sum to negative 5, which is exactly what we wanted. Now, previously, we'd be basically done. We would just sort of shove those numbers into our linear factors. But here, we actually need to split the middle, that middle term. Okay, I want to show you what happens when we do that. So actually split the middle term. Because we'll have to get our hands dirty and actually do a little bit of factoring. So our quadratic is 3x squared minus 5x minus 2. I have that middle term, and I'm going to split it up in the following way. So I'm going to write it as plus 1x minus 6x. Okay. I've taken that negative 5x and I've written it in this slightly less simple way. And we'll see in a second why that's actually a really useful thing to do. Because now all we're going to do is we are going to factor in pairs. So the first two terms, the 3x squared plus the x, well, there's a common factor there, right? I've got that common factor of x that I can pull out, and that will leave behind 3x plus 1. And in this second pair, this negative 6 minus 2, I've got a common factor of minus 2 that I can pull out, right? So I've got minus 2, and what does that leave behind? Well, it leaves behind 3x plus 1. And that's worked out really nicely, hasn't it? Can you see why? Well, what I've left behind in each of those terms is 3x plus 1. So we picked the numbers just so that happened. Okay? So now what we'll do is we'll factor out that common factor 3x plus 1. Okay, so I'll pull it out to the front. Here it is. And what does that leave behind? Well, I get an x from the first term, and from the second term, I have that negative 2. So I get my x inside my parentheses, and I get my negative 2 inside my parentheses. Now, I'll leave you to check by foiling out that this does indeed give us our original quadratic back, but what I want to focus on now is just a couple of caveats. Okay? So I mentioned previously in our last video that not every quadratic polynomial does factor nicely using whole numbers and integers, but just like then, the same is true now. If it can factor nicely, this method will work. Okay? It will get you that nice product of nice factors. What can go wrong? Well, notice there was a little something that happened with a minus sign. Okay? So this minus sign, I was certainly able to factor it out because it was part of the negative 6x and part of the negative 2. But notice if I hadn't done that, this 3x plus 1 would actually be negative 3x minus 1, which would cause some problems when I try to pull out this common factor of 3x plus 1. So if you get to this very late stage in the game and stuff is not quite working out for you, check that minus sign right there, because that can trip people up. If it all looks fine, I'd return up here to our factor pair calculation. Make sure we've found the right factor pair. If that all looks good, make sure we've extracted the correct 3 numbers from our quadratic in the first place. And if you'd like 1 more minute of math, although in this case it will be a little bit more than 1 minute, I suspect, what I'd encourage you to try is to figure out why this process actually works. So reverse engineer the split the middle method by expanding the slightly general looking product px plus q times rx plus s, and see if you can see that relationship between the factor pairs summing to the x coefficient arising out of your expanded expression. And if you'd like to do X minutes of math, Y more times, don't forget to subscribe to this channel.